Now let's solve question number 6, which is about consider the curve given by the equation 6xy equals to 2 plus y cube. Show that dy by dx equals to 2y over y square minus 6x. So in order to find this out, or in order to show this, you have to take the derivative of this function with respect to x. So here 6x and y. So you have to apply the implicit differentiation. And we know that when x and y coordinates are given together, then you have to use the product rule. That is fg prime plus gf prime. So in this case, your f is 6x and your g is y. So fg prime, what is f? F is 6x. G prime is y. Okay, so dy by dx you can write. Plus g is your y, and derivative of f with respect to x is 6. Equals to, do the same thing on the right hand side. Derivative of 2 is 0. Now here you will use the chain rule or the implicit differentiation. So bring the 3 in the shoulder, write the y. From the power subtract 1 and now take the derivative of y with respect to x. Now solve. Means bring all the dy by dx on one side. So if I bring the dy by dx on this side, so I will get here 6x dy by dx minus 3y square dy by dx. Now bring this y 6y on the other side, you will get negative 6y. Now from here, from the left hand side, take the dy by dx common. So here dy by dx common, and also from here you can take the 3 common. So you can take 3 dy by dx as common. So now if you divide here by 3, you will get 2x minus, if you divide here by 3, you will only get y square equals to minus 6y. Now if you just have a look and in a glance you compare this thing by this thing, you want to change the, you have to change the position of these things. So if you take the change the position, okay, so it means you have to take the negative in the negative as a common. So if you take the negative as a common, look at this one. If you write the negative here, so this will become negative and this will become positive. So that's so simple. Otherwise from this part, rather than bringing the 6y square on this side, bring the 6x on the other side. So anything you can do it. Now divide both sides by 3 and y square minus 2x. Here also 3 and y square minus 2x with the negative 3 better. So this cancel, this all cancel, negative negative cancel, and this will give us 2. So you will get dy by dx equals to 2y divided by y square minus 2x, which is same as this equation. So in the end you can write it as proved. Now in this part they are asking you find the coordinates of a point on the curve at which the line tangent to the curve is horizontal. What is meant by horizontal? Horizontal means that the derivative is equals to 0, which means that the slope of the tangent line is 0. Or explain why or why not such point exists. So first of all, you have to solve for the derivative and make it equals to 0. So from the first part, they already gave us that dy by dx equals to 2y over y square minus 2x. So I can write it 2y over y square minus 2x equals to 0. Now cross multiply. When y square minus 10x minus 2x will be multiplied by 0, it gives you 0. So on the top we will be left only by the 2y. Divide both sides by the 2, so you will get y equals to 0 by 2 gives you 0. Now put this y coordinate in the first equation. Okay, so you will get 6x in place of y just replaced by the 0. So 2 plus 0 cube. So what have you get? Anything multiplied by 0 is 0 and 2 plus 0 is equal to 2. Now, can you just say that 0 equals to 2? No, 0 cannot be equals to 2. If the left hand side and the right hand side are not equal to each other, it means that there is no such point where the line tangent to the curve is horizontal. So you will write here, since the left hand side is not equals to the right hand side, or 0 is not equals to 2, there is no such point where the line tangent to the curve is horizontal. Please, in the free response questions, try to write everything. Do not use the short term, do not use the pronouns, because it affects your marking. And even if you do not write the statement, that will not lead you to gain the full marks. Okay, so if the students leave their answers over here thinking that the rest of the answer the examiner will think themselves, so they are on the wrong path. They should write the complete statement in order to finalize or finish the question. Okay, so find the coordinates of a point on the curve at which the line tangent to the curve is vertical. What is meant by the vertical? It means the derivative of the function is undefined. That means the slope of the tangent is undefined. So if we look at the derivative, when the slope will be undefined, when the denominator will be equals to 0. So here, since already the derivative is given, so the denominator is equals to 0. If the denominator is 0, it means that the derivative is undefined. Now solve. Now if we solve for the y, since it has a power 2, so it will give us a little complicated equation, although it would be right. So I would prefer to solve for the x, because it seems easier for me to solve for x. Bring the x here. So you will get 2x equals to y square. Divide both sides by the 2. So you will get y square divided by 2. So x equals to y square by 2. Now put this value of x in the first equation. In the first equation, so we will have here 6x, and in place of x I will write here y square over 2, and in place of y I will keep the y as it is, 2 plus y cube. Yes. Now solve it. So y square times y gives me y cube, and 2 and 6 will be cancelled out, so I will get 3y cube equals to 2 plus y cube. Now bring the y cube on the other side, so I will get 3y cube minus y cube equals to 2. So 3 minus 1, I will get 2y cube equals to 2. Divide both sides by the 2, I will get y cube equals to 1. In order to solve for y, I will take the cubic root on both sides. So on taking the cubic root of the y and the cubic, I will get y. Cubic root of 1 is equals to 1. Now to get the other coordinates, I will replace the y as 1 in the x value. So x equals to y square, y is 1, 1 is square over 2, which will gives me half. So the coordinates x and y, so x is half and y is 1. Now I have to prove that the left hand side is equal to right hand side. If it is so, then it means that there will be a point where the tangent line to the curve will be vertical. So I will put the values of these coordinates in my equation. So I will write here check. So 6 in place of x I will write half. In place of y I will write 1 equals to 2 plus in place of y I will write 1 cube. So 2 plus 1 cube will give me 3 and 6 times half times 1 also gives me 3. So I can write here, since left hand side is equals to the right hand side or 3 equals to 3, there is so I can write the coordinates the coordinates half and 1 on the curve are there are coordinates, the coordinates half and 1 are on the lie on the curve at which the line tangent to the curve is vertical. So remember that anything if they are asking you, you have to check in the end to get to give the perfect answer, and do not give the chance to your examiner to take your marks. Now last part D is a particle is moving along the curve at the instant when the particle at the point half and -2, its horizontal position is increasing at a rate of dx by dt equals to 2/3 unit per second. What is the value of dy by dt, the rate of change of the particle's vertical position at the instant? Now have a look here. So our equation is 6xy equals to 2 plus y cube. You have to differentiate the function with respect to time. So with respect to time, it means x is a function and y is a function. So again, apply the product rule. So let's see here. Try to understand this here. So f is your 6x and g is your y. So what is the derivative of 6x? 6 as it is. The derivative of x with respect to time is dx by dt. Now derivative of y with respect to time will be dy by dt. So now use the formula fg prime plus gf prime to solve this equation. So f is 6x, g prime is dy by dt, plus g is y, and f prime is 6 dx by dt equals to the derivative of any constant is 0. Derivative of y cube using the chain rule or the implicit function, you can write 3y square, and now the derivative of y, that is dy by dt. Now since they are asking us to find the dy by dt, so bring all the dy by dt on one side. So let's bring this dy by dt on the other side. You will get 3y squared dy by dt minus 6x dy by dt. On the left hand side, we will be left with 6y dx by dt. Now dx by dt is equals to 2 by 3. The value of the y is negative 2 and 6 equals to 3. Y is negative 2 whole square. Dy by dt you have to determine. Minus 6, what is your x? X is half. And dy by dt you have to find it out. So you will get here negative 2, 4 times 2, 8. So here you will get negative 8 because yes, equals to 2 times 2 is 4, 4 times 3 is 12 dy by dt minus 2, 6, half of the 6 is 3 dy by dt. So 12 minus 3 gives you 9 dy by dt equals to negative 8. Divide both sides by the 9 to get the final value. So dy by dt equals to negative 8 over 9 because we divide both sides by the 9. So you can say the value of, in the end you have to write the value of dy by dt is negative 8 over 9. Or you can write the rate of change of the particle's vertical position at half and negative 2 is negative 8 by 9. So that is how we solve the free response questions in a proper way. So see you next time with other year's free response questions.